Hello everyone, welcome to my last little video, my last little vignette on Chapter 8, Stoichiometry. So all of the chemical equations that we have looked at so far, when doing calculations with them, we've been using units like grams, moles, we just introduced molarity and volume, how we can use those units to calculate amounts of reactant and product. But you guys also should remember from previous chapters that chemical equations, they not only involve mass, but they involve heat. And that heat in a chemical reaction can either be a product or a reactant. When we talked about heat in previous chapters, we gave it that variable Q, and we used that variable in certain equations to calculate heat. You don't need to remember those equations for this chapter, but you do need to remember these two terms that talk about if heat is absorbed in a reaction or if heat is released in a reaction. So just like we said in chapter 3, I think it was, if the heat associated with the reaction was positive, that means that the heat was absorbed by the reaction and it's an endothermic reaction. Conversely, if the heat associated with the reaction is negative, that means that reaction is losing heat. It feels hot when you touch it because it's losing heat, and therefore that reaction is exothermic. Okay? And the units that we used to talk about heat were primarily joules, sometimes kilojoules, sometimes calories, but primarily we used the standard international unit of joules when talking about heat. So we're going to talk about how we can use heat now in chemical equations and stoichiometry, but we need to introduce one or two more topics. So when we talk about heat, we gave heat this variable Q. Chemists have another variable that they like to use to designate heat, and it's this fancy word called enthalpy. If you go on to take thermodynamics classes, you'll talk about enthalpy in the third law of thermodynamics. You just need to know that enthalpy, it's a fancy word for heat, and it has the variable or the symbol delta H. And this little subscript here means reaction. That just means this quantity is a measurement of how much heat is either absorbed or released at a particular pressure for a particular reaction. So, for example, in this reaction I have listed down here, I have calcium carbonate solid as a reactant. The two products are calcium oxide solid and carbon dioxide gas. And the enthalpy, the heat that is associated with that reaction, it is an endothermic reaction. It's an endothermic reaction because of the positive sign. And the heat that is absorbed from that reaction is 178.1 kilojoules. Okay? So aside from the importance of the actual value of the heat, how much heat is absorbed or released, that sign is going to be important as well. Okay? So here's our balanced equation again, and the heat. That was from the previous slide. So we know from this statement or from this chemical reaction that 178.1 kilojoules of heat is absorbed upon this reaction. But we can also say something about the amount of heat that is, in this case, absorbed based upon the coefficients of the balanced chemical equation. So if I was just to give you this chemical equation, you would say, oh, I know for every 1 mole of calcium carbonate, I have 1 mole of calcium oxide and 1 mole of CO2. We can also add to that statement that I know for every 1 mole of the calcium carbonate, I get 1 mole of calcium oxide, 1 mole of carbon dioxide gas, and I get 178.1 kilojoules of heat that is absorbed. So and what I just said is written down here. So just like you can use coefficients from a balanced chemical equation to write relationships as conversion factors, I can use the amount of heat that is absorbed or released in a reaction that will be given to you in the problem to relate moles of reactant and product to amount of heat. So if I was to put a 2 in front of all of these species, if I was to not decompose 1 mole of calcium carbonate, but 2 moles of calcium carbonate to give me 2 moles of calcium oxide and 2 moles of CO2, I bet you could guess what would happen with the amount of heat. If you put more logs on a fire, you get more heat out. So those coefficients increase the amount of heat. So if I multiplied all of my species by 2, I would have to multiply this by 2. Okay. So chemical equations involve heat. The amount of heat that is absorbed or released is related to the coefficients of a balanced chemical equation. And just like we were able to use those coefficients as conversion factors, we can use heat as a conversion factor as well to do stoichiometry problems. So let's say that you're going to enjoy this beautiful day that we have. At least right now it's about 80-some degrees out. You want to do some barbecuing with your family? And let's say you know that your home barbecue tank has this amount, 11.8 times 10 to the 3 grams of propane. And you want to know how much heat in kilojoules is associated with completely burning or consuming all of that reactant. And I give you the balanced chemical equation for that combustion reaction. So when looking at this balanced chemical equation, I can say for every 1 mole of C3H8, I have 5 moles of oxygen, 3 moles of CO2, 4 moles of water, and I have 2,044 kilojoules of heat that is released, exothermic. That's good information to know because we can use that relationship, specifically the relationship between amount of C3H8 and the amount of heat that's released to do stoichiometry calculations. I don't know how much heat's released with 11.8 times 10 to the 3 grams, but I do know for every 1 mole, I get this. So I take what is given, I convert it to moles using the molar mass of propane, C3H8, so 3 carbons plus 8 hydrogens. Once I do that, I'm in moles of propane. I can easily go from moles of propane to heat released by the coefficients of the balanced equation and the heat. For every 1 mole of C3H8, I have that much heat that's released. Setting it up like this gives me an answer in kilojoules. This negative sign just means that the reaction is exothermic. I have lost this amount of kilojoules of heat. So, stoichiometry makes use of those, not only the coefficients of the balanced chemical equation, but you can also use any heat that is associated with the reaction to do stoichiometry problems. So there is a similar problem, number 8B on your Chapter 8 worksheet. I would encourage you to work that one and check the answer. The answer key's on Canvas as well. And that is the end for Chapter 8.